Welcome to the live stream of the Terran 1 vehicle by Relativity Aerospace. I'm Josiah Coy, and I'm the chief engineer at a group called ASTRA, which operates out of Bremen. We're just a student group that's trying to build rockets, and yeah, we're here to see this rocket launch. Hopefully, this time. We've streamed the first two attempts that happened about a week ago, so maybe we'll get to see a successful launch today. It's a bit of an early one here in Bremen. Right now it's 2:30 in the morning, so bear with me. My head might be a little bit slow. I might, I might need an extra cup of coffee here and there. We'll see. But yeah, depending on where you are in the world, though, it's maybe not in the middle of the night for you. At Cape Canaveral, which is where they're going to be launching this rocket, it's going to be just in the evening, so kind of a nice time to see a rocket launch, hopefully. I also hope it's not going to be in the dark. If it's dark there, that's going to kind of suck a little bit, because then we won't get to see it as well. So I hope they're going to end up launching this hopefully in the earlier part of their launch window. But yeah, we'll see how that goes. So for the Terran 1 vehicle today, just a little bit of context. It's a new vehicle that's being built by Relativity Aerospace. And it's a little bit special because it's going to be a 3D printed rocket. So like the entire rocket that they're launching today is 100%, well, not 100%, it's 85% 3D printed. There are, of course, some parts that you can't 3D print, like seals and, you know, hydraulics and stuff like this. But everything else is 100% 3D printed. Even the tanks and everything. So it's really a kind of a new innovative approach to building launch vehicles. And basically this rocket is the opportunity for them to test that. And that's what makes this kind of interesting. Anyways, as I said before, there have been a couple of hiccups on the first two attempts that they had. So on the first attempt, they had a 3-hour launch window. This was about a week and a half ago. They had some issues with the actual range. There was a boat that got in the way on their first try. And then the second try, they had some issues with the filling process that they were doing. So they called it propellant conditioning. And this was just a problem with basically how they were filling the tanks. And there's an issue if the methane stays inside of the tank for too long. The ratios of methane to other products kind of starts to go out of whack. And then basically it prevents the launch from happening. A bit of a unique issue for methane-powered vehicles. So stay tuned about talking more about that in the coming minutes as we basically discuss what's going on with this rocket. Then on the second attempt, they were back a couple of days later to try and see if they could launch it again. But again, they were having some troubles with, this time, the weather. And then once they finally were able to find a slot where they could launch, they ran into some technical issues with the rocket. They came all the way to T-0, lit the engines, and then decided to scrub right before they launched the rocket. They had some issues with the conditions for the launch, so some sensors decided, the pressures weren't exactly right, stop everything. They tried to recycle, and they actually got it. They tried to recycle again, right after they had just lit the engines, which is very weird for a rocket. Usually once you light the engines, that's it for the day. But unfortunately, when they tried to recycle again, they ran into another technical issue, and so they just decided, okay, we're scrubbing for the day. So that brings us to today. Now they're going to basically try to launch this rocket again. Hopefully they've solved all their technical glitches, and I also hope the weather is going to cooperate with them today, and that there should be no range violations. These are usually the things that get in the way: technical, range violation, and weather. So hopefully all those things are cleared up today. To give you a little bit of an idea of what the timeline is going to look like for today, basically they have a 3-hour launch window, which is going to be starting in about 30 minutes. So at that point, which is I think 2 a.m. UTC, from there until 3 hours later, which is 5 a.m. UTC, they can launch this rocket at any time, basically. So there's not like an instantaneous launch time, right? They can, kind of scrub, come back, and kind of reset themselves anywhere within that time window. So if they do have a delay or a pause in their launch sequence, don't freak out and think this is the end for the day. Relativity is actually pretty good at trying to do multiple launch attempts on the same day. So we might see this kind of go through the launch countdown a couple of times if history is any guide. For that reason, I'm not putting up a clock that's counting down exactly to when the launch is because, well, no one really knows when the launch will be. So we just have to kind of follow relativity's clock and kind of go by the callouts they give us. Yeah, anyways, really excited to see how this is going to go. In the meantime, though, we can kind of start to figure out what exactly is going on with this vehicle and see what makes Relativity's Terran 1 so special. Hey there, Javier. How do I say your name? Javier? Javier? Sorry, I'm totally murdering your name. Yeah, in Germany right now it is 2:27 a.m. So not quite, a little past 1 a.m. Yeah, but that doesn't stop me from wanting to talk about rockets. I'm good to talk about rockets at any time of the day. Javier. Javier. Okay. Yeah, the J is a silent one. You must be Spanish in descent. Cool name. So for the Terran 1, that's the vehicle that's going to be launching today. It stands at about 35 meters tall. For a bit of context, that's about as high as like a 10-story building. So it's quite a large vehicle. It also has a main diameter of 2.3 meters. The dry mass, so when you have all the fuel out of it, it's around 9 tons. The key thing here, though, is that the payload capacity is just over 1 ton, 1,250 kilograms to low Earth orbit. That means that it actually slots into the medium class launch vehicle category. It's not really a small sat launcher. So it's going to be competing in a market which is kind of not so many vehicles in it right now. And it seems like a lot of the launchers that are being built today are kind of starting to slot into this category instead of the small sat launcher category. So this is an interesting trend in the market. The vehicle also has 2 stages. So it has a core stage and then it has an upper stage at the very top. And yeah, you'll kind of see how that works a little bit more as we go along here. All of this rocket that you're seeing there, like all the structure components and the nose cone and everything else, that is all entirely 3D printed. And that's what makes this rocket special. So basically, Relativity Space has these giant bays in their factory. They're those big silver doors there, you can see. And they have these machines that are in there that actually do the 3D printing of the rocket. And it kind of works similar to how just like a regular plastic 3D printer works, except it's a little more advanced. And it actually prints aluminum. And this is kind of a novel way to do it because historically, the way you 3D print metal is you basically have like a little box and you have like powdered aluminum that gets put down for each layer, and there's a laser that kind of melts it all together. And it takes really long to do this, of course, because each layer of powder is very thin, and there's kind of a limit to how big you can build a 3D printed part like that. But with this technique that they have, they call this WAM. I don't exactly know what the WAM stands for, but in this case, they're not actually using the powdered aluminum and then doing the melting with the laser. They're actually like having a filament of aluminum that gets fed into this like 3D printer where there's a nozzle. It's melting the aluminum and like melting it into place. So it's kind of just like a normal 3D printer, except that they do it with aluminum. This allows them to print much bigger things. And basically this is what allows them to print the entire rocket. They have to overcome a lot of little technical things because of this style of doing it. One of the main hurdles there is the way that aluminum shrinks and grows with response to temperature. So obviously when you are layering that aluminum on, it's really hot, and then as it cools, it's going to shrink and contract. So they actually have a special software tool that basically analyzes how the aluminum is cooling so that the printer will compensate for that as it prints. And that's really the secret sauce for how Relativity Space is utilizing the 3D printed technology in a way that is actually very valuable for the future. Because with this, they can, essentially 3D print any type of major structure out of metal, which is, at least in the near term, I would say a very valuable technology. Yeah, they've chosen rockets as their first vehicle for testing this technology, and I think it's an excellent one because obviously rockets are subjected to huge loads. So if they can show that it works for a rocket, there's a lot of other future possibilities that it could work for. Here's a little bit of an idea of how the printer actually works in this time lapse here. So you can see how basically it's just layering stuff up. You can see the robotic arm moving there, and that is where the filament is being put through the nozzle and being basically melted onto the print. And you can see here also that they have a spinning print bed, which is basically designed for building a rocket. So it's not like the XY print beds that we have on our home 3D printers. This is kind of more optimized for rocket building. You'll notice that they don't actually print the entire rocket in like one print. They just print sections, and I believe that the whole main stage of the tanks and everything is actually 5 stages of these tanks that they build up, and they will basically bolt those together, and then that's what forms the main body of the rocket. But it's pretty crazy that they've boiled down like an entire rocket that is usually like tens of thousands of parts into just a few parts, and that's kind of another magic part of 3D printing, is it makes assembly so much faster and so much easier. Yeah, it is basically a pottery wheel, kind of, except they're not they're not forming it like pottery; they're just printing it. But it kind of works on the same principle, essentially. What's really interesting about this is that it doesn't just have to work for rockets. Like, you could apply this technology to like a lot of other things that exist in the world. So, and also things that are existing in space as well. Like, if we could take one of these 3D printers to like to low Earth orbit or something, you could build stuff in low Earth orbit. If you take it to another body like the moon or to Mars, you could build stuff there, like habitats, maybe even rockets to get yourself back home, things like this. So it really opens up a whole world of possibility, and this is the first test of something that can work like this at scale with some serious stresses, and that's why I'm excited to watch this thing launch today. With all that in mind, let's take a little bit of a look at what's actually powering this rocket. I'm a bit of a propulsion aficionado, so it's always good to see what's underneath the hood. So here you can see that there's the Aeon engines are going to be what are powering this rocket. It's a 100 kilonewton engine, and there are, I believe, 9 of them on the bottom of the rocket. And they're also 3D printed, so it's using, again, 3D printing technology. In this case, it's not using that WAM printer that we just saw. It's actually just using the powder that they use, and then they use the laser to melt it. This is because they obviously can't use aluminum to 3D print rocket engines, because aluminum melts at such a low temperature. But there are advantages to the standard method, which is with that powder, is that you can do a lot more intricate things, like little tiny small details. And they have to do that because in order to cool these engines, they actually feed the liquid methane into the engine bell, and that like helps it cool down the combustion chamber and the nozzle. The beauty of 3D printing is that you can 3D print those cooling channels right into the walls of the combustion chamber and the nozzle. So you don't have to, use a whole bunch of machining and tooling in order to make that functionality. And if a good example of this would be the space shuttle engine. If you ever get a picture of that, you see like the cooling channels on the outside, and like they've painstakingly machined all these channels and like placed them onto the nozzle in exactly the correct orientation and everything. And that type of manufacturing just takes a lot of time, takes a lot of effort, and eventually a lot of money. So this is the advantage that you get with 3D printing. Like I said before, the engine's running on methane and oxygen, and both of these are cryogenic liquids. So the entire rocket is cryogenic. This is a little bit different from like the standard way of doing rocketry, which is with kerosene and liquid oxygen. In this case, the kerosene is not being stored at cryogenic temperatures. So yeah, in this case, I don't know if it's really advantageous for operations. Like I discussed before, they sometimes have issues with liquid methane because it's kind of a new fuel to be using. But in the end, you do get a lot more specific impulse with methane and oxygen, which is kind of why I think companies are moving towards that option. You get higher performance. But yeah, they've done a lot of testing with this engine. They're at many tests, over 500 now. Even had a little bit of an extra test just a couple of days ago with uh, their last launch attempt. They got a little bit of a static fire going there. Here you can see one of their tests. Basically what they do is they just strap this thing to the launch pad and light the engines. So essentially everything should be kind of the same operationally between this and the launch. So yeah, they even got, like I said, they even got the extra hot fire test just last week in the last launch attempt. This engine has a lot of testing underneath it, so hopefully it's going to be strong enough to get it to orbit. In terms of the rundown of what we should expect today, the rocket's going to go through a couple of stages once we get to the actual launch pad. But before we get to the launch pad, there are a couple of key milestones that we should be looking out for. The first one comes about 24 minutes before the launch. And there we're actually going to see kind of like a pre-check to make sure everything's okay. So they're going to check on weather, they're going to check on range, and they're going to check on vehicle health. And they're going to decide, okay, are we still a go? If so, the clock will continue. Then at around T-minus 15 minutes, they're going to basically do their go, no-go poll. So this is where they're going to go through every single department that is responsible for the vehicle and figure out if they're a go to launch. Once we've passed that milestone, we're basically in the good phase of getting close to the launch. The vehicle is going to be in the last phases of getting ready. It's going to be just finishing its fueling up. It's going to start. It's going to start getting ready to actually do the launch. About 3 minutes to the launch, you're going to see the big. There's like a big piece that kind of holds the rocket. It's called the strong back, and it's like holding up the rocket, and it's where they're filling everything from. You're going to see that piece kind of pull back, and that's an indication that they're like in the serious part of the getting ready to launch. And then finally, the last milestone that you should look out for is the 70 seconds before launch, because this is like their threshold for when they decide whether or not they're ready to launch. They can basically call a hold up until T-minus 70 seconds. After T-minus 70 seconds, so coming closer to the launch than that, they can't really call a hold. Basically, they have to call a scrub. So this is kind of like a critical boundary. And they might just stop the clock right before it because sometimes they're a little nervous and they just want to, check everything one more time. But yeah, once they roll past that, then basically we're at the launch. So T-minus 0, vehicle will launch, engines will light up. Hopefully the launch clamps will let go. The vehicle will ascend. After about T-minus a minute or so, the vehicle is going to go through what's called maximum dynamic pressure. This is a critical milestone because this is where the most force is on the structure of the vehicle. And of course, one of the main things for this whole thing is to test whether 3D printed structures are good enough for a rocket. So if they pass this milestone, that's kind of like proof of that concept. Then at about T+3 minutes, you're going to see the first stage run out of fuel. It's going to separate. And then that second stage will then ignite and carry the payload the rest of the way to orbit. There's no nose cone on this particular version, so you're not going to see like a nose cone deployment or anything. Instead, there's just kind of like a nose cap, and that's protecting a little tiny payload that's only about 1.5 kilograms. This is one of their first prints that they ever made, and it's like kind of like a sentimental value payload for them. There's nothing, they're not like sending a paid payload here. It's just a demonstration mission. So nothing too crazy there. So yeah, that's kind of the rundown of events you should expect. One thing to keep in note is that the vehicle is not going to be reused or anything, so there's no reuse built into the rocket. It can't return to the launch site. It's just the first stage is going to go crash into the ocean, and the second stage will hopefully get into orbit, and then it'll deorbit itself. So it's not a Falcon 9 style reusable launch vehicle. So we're about, we should be around, 30 minutes or so away from the start of the live stream. It looks like they delayed the live stream a little bit while I was talking there. Just to remind you, we are here for the relativity, the relativity launch of Terran 1. They do have a launch window that starts in about 15 minutes, and that's going to go for 3 hours. And because this is a test vehicle, I do expect that they will make full use of that 3-hour launch window. Basically, if the past is any guide, they will probably have multiple attempts to try to launch this today. Hopefully, one of them will be successful. They have had 2 attempts in the past. Like about a week ago, they had 2 attempts. So hopefully the third time's the charm. So, one thing to think about with Relativity is they're not just a launch company that's trying to launch this Terran 1 vehicle. This is just kind of like their starter mission. They have really big plans for the future, and I want to talk a little bit about those plans before we get into the official live stream here. So here we can see that WAM printer again. And basically, it's building up the part by doing those layers, kind of like a 3D printer. And here you're really getting to see the true potential of what this 3D printer is capable of. So this is like a giant bottom of a tank that's being printed here. For context, the diameter of that is about 6 meters. And you may be wondering, what the heck is this thing printing? Well, it's actually printing the test piece for the Terran R. This is a vehicle that is slated for the future right now, and essentially it should have the capability to be a fully reusable vehicle. So obviously Relativity has, figured out that if you want to be competitive in the market in the future, you do have to build reusable vehicles. So the Terran R is basically their response to this. So the Terran 1, which is going to launch today, is just a Pathfinder rocket. So it's their first rocket that they want to test this 3D printing technology with to make sure that it's, sound and can be good for orbital vehicles. And then the future plans are basically to eventually move to this Terran R vehicle, which will be able to do hopefully a lot more. And just to give you a little bit of a comparison between what's planned here, you can see here on the left-hand side of this little diagram here, that's the Terran 1, just on the left there. And on the right is the Terran R. So you can see it's quite a lot larger, like about 2 times as tall. It's going to be around 60 meters tall. And also quite a bit wider, at almost 6 meters wide. And you'll also notice it has a striking similarity to the Starship vehicle. So it might have some similar specifications. It'll just be a little bit smaller. But they're planning that this will be a fully reusable vehicle. So basically that core stage will probably fly back to a drone ship or maybe back to launch site or something. And that second stage will go to orbit and then also deorbit itself and probably land somewhere as well. And of course, their plan would be to also fully 3D print this rocket as well. So yeah, lots of big, bold plans coming from the Relativity team. Definitely looking forward to seeing if this will also be possible in their future. So that's kind of what we should be looking out for in this launch today, is that not just seeing the single launch today as being like, something, but also looking to see what exactly the whole plan is for this company and where they actually want to take this technology. As I said before, there's a lot of other applications of this technology. It's not just building rockets. So we'll also probably see relativity expanding into new markets, so to say, not just the rocket building market. Like I'm sure there's lots of potential for them to be building, things in space. So if they're able to figure out the technology to the point where they could actually put this into a rocket, uh, building things in space with 3D printing would be definitely a really cool idea. I'm sure there's lots of other manufacturing industries on Earth that would be interested in 3D printing metal, like automotive or something. Definitely awesome for prototyping. You could just 3D print a design out of aluminum and be like, boom, all right, let's try out this new type of a car or something. What I'm most excited for this 3D printing technology is what it can do for like human expansion into the solar system. One of the biggest problems that you have when you're trying to get to like the moon or try to build a colony on the moon or a colony on Mars or something is that you can't like bring all the tools that you have on Earth in order to do that. So you kind of have to bring everything like pre-assembled. So if you want to build a habitat on the moon, at the start you would have to literally like build your habitat on Earth, put it on a rocket, and then like land it on the moon. Like that's basically the most realistic way we can do it with the technology the way it is today. But if you think about this, like if you're able to get a tool like a 3D printer to the moon, which, if you look at the size of the Relativity 3D printers, it wouldn't be out of the question that you could put that into like a Starship or something. Once you have that like tool there that can do this type of stuff, you could use that to build stuff there. And that would kind of eliminate your need to, bring something completely pre-assembled. All you would need is aluminum to feed it, and it can create stuff. Yeah, you couldn't do that with current technology because like you would need a whole bunch of different tools, and these would just be, ridiculously complicated and require supply chains and like technologies that are just beyond the purview of being able to send them to the moon. So I think that relativity is well positioned to hopefully maybe address some of those other things. And maybe in the future we'll see them hopefully selling their 3D printing technology to other companies so that they can use it and bring some of these other things to life. So yeah, think about that while the launch is hopefully happening today and what the true potential is of this technology, because I think that could be very impactful for the future. But another question you might have is, okay, the Terran 1 is clearly a medium class launch vehicle. How does it compare to the other launch vehicles that are out there? Because there's like a whole bunch of other companies right now that are trying to build rockets to go to space. Like how does the Terran 1 compare in terms of capability and economics and things like that? Well, one good comparison that we have is to the Firefly Alpha, which is also a medium class launcher. It's also going to be trying to launch payloads in the class of about 1 ton, just over 1 ton, into low Earth orbit. And you can see here, this is them compared to each other. So Terran 1 is a little bit taller, a little bit wider, produces a little bit more force, can lift a little bit more payload into low Earth orbit. But when it comes to the cost, you can see that it is a little bit cheaper. So right now it's being marketed at about $12 million, whereas the Firefly Alpha is marketed at about $15 million. One thing to think about this though is that I think that Terran 1 has a lot of potential to bring that cost down, because like this is the point at where they're just building the 3D printing rockets at the start, and getting that whole process going is kind of an expensive process. So I think once they get their like economy of scale going, like printing these rockets in a factory style kind of way is going to be like really, really like a competitive advantage against other ways of doing rocketry. Because one of the biggest costs that comes to rocketry in terms of building the rocket is the actual assembly. That takes time. It takes a lot of effort, especially when you have so many parts. It's also like a failure, a potential for failure, because every single part has to be put in exactly the right way. And if there's like one mistake, like that's the end of your rocket vehicle. So the more you can reduce the amount of parts you have and reduce the assembly steps that you have, that's an opportunity to enhance the reliability and also to reduce the cost, because you don't need as many people to be there, assembling everything. And there's just like less time that's required as well. So yeah, that's going to be something where they can really benefit. Yeah. Did it get moved? I'm assuming you're referring to the actual launch of the rocket. It's not technically officially moved. Let me just check Twitter. They might have something on Twitter saying what's going on. They have delayed the live stream a little bit. They pushed it back about 30 minutes, but they haven't released an official statement as to saying that it's not good. They say that the weather is looking good as of 2 minutes ago. They have a bunch of weather balloons that go up into that they launch in order to test out the weather. So basically they like launch these weather balloons and they are sitting at different altitudes and they're continuously measuring and monitoring the weather data. The main thing that they're worried about are the higher altitude winds, like at around 10 kilometers or so. Right now it's trending and looking like it's good. So I think that they're probably going to be good for launch in terms of weather, at least today. I think the mainstream is going to start up in about 10 minutes or so. So yeah, hang tight until then. I didn't see the fake Relativity live stream. I didn't know someone was faking it. If that's the case, then yeah, make sure that you're watching the official Relativity Space channel's stream. I'm not sure if we're waiting right now because of higher upper level winds. They're saying right now that the upper level winds are trending positively. So I think that they might have delayed the first little bit, but I think they're probably gonna start the clock anytime now, and they'll probably start it from like 45 minutes or something. So yeah. Sometimes this is something I've seen on YouTube a lot these days. Like people will just like live stream like old stuff, and like for some reason, like people will click on it. I don't know. Usually they put like Elon Musk's face on it, and it's like updates, and then they try to clickbait you into watching the video. Sometimes it's kind of annoying, to be honest. But yeah, I think they have a good chance to launch today because the weather does look nice. Assuming the upper level wind thing is not going to be an issue. And they have had an opportunity to work through their technical issues. So I think that in terms of the probability of the launch being successful from a technical perspective, it's definitely a lot higher of a chance now because they've had 2 dress rehearsals where they even lit the engines last time. So like they've done everything except release the clamps. Yeah, and they tend to be a little bit jittery with this launch for some reason. Like when they said no go on the last one, like they had a pressure value that was out by like 1 psi. So it's like, I don't think that would have caused the rocket to fail, but okay. I mean, if you can just 3D print your rocket, like why are you so... You can just make a new one. It's no problem. Yeah, what do you guys think is the probability this one will be a go? I think it's 60% they launch, 40% they don't. Which is actually less probability than I gave for the second. On the second attempt, I thought it was 70% go, 30% not. So I've gotten a little more conservative. Yeah, tell me your thoughts. 1 for go, 0 for no go. Looks like we're all on the go side. Yeah, I hope the reality is as positive as you guys are. Yeah, I definitely think that the two dress rehearsals I've had so far have really demonstrated that the vehicle is actually quite healthy and that their operations are quite uh, all encompassing, should I say. They're very nitpicky with the details of making sure everything's good. So uh, it's definitely inspired a lot of confidence that they will actually have a successful launch even. Wow, Tyler, you're camped out at Cape Canaveral? That's awesome. I wish I could be there. Definitely watch out for the, the awesome sight and the deafening sounds. One problem with being in Europe is you never really get to see like a high power, like a proper orbital launch because there's like no orbital launches that happen out of Europe. The problem here is that there's people everywhere and we don't really have ocean going to the east. So all the European launches go to uh, down into French Guiana instead. So it's really an awesome opportunity to be able to actually see these things in person. The best thing that we have is to build our own rockets and try to launch them. But I guess it's not really the same as an orbital class launcher. To give you some context on that, I am from a student group which is trying to build a rocket which will go to space. Uh, we're in the depths of doing that right now. We have a propulsion test that's coming up in a couple of months, so things are getting exciting. Yeah, wow, that's awesome. If it launches today and you get lucky enough to see it actually launch on the day that you were just told, like, oh yeah, there's a rocket launch today, uh, that would be awesome. And definitely sign up for a lottery ticket because that's kind of rare. Yeah. Yeah, we're considering to live stream the test. It might be a little bit difficult because it's kind of internet connection might be a little bit tough there. But our intention is to try to live stream some of our key testing moments and definitely the launch as well. Uh, yeah, but I can't make any promises. It depends on how much staff we have to be able to pull that off. But I would love to live stream it. I think that would be fun. Yeah, it's 3 a.m. in Germany. Yeah, I have much coffee in me, but I'm really excited to see this. So I wouldn't miss it. I hope they're gonna start this process up pretty soon here. Let's see what the Twitter is saying. So we've just been given a T minus 0. It's 22:38 Eastern time. I think that's Eastern time. EDT. I actually don't even know what that is, but it's in 38 minutes. They've just announced that T minus 0. So start your clock. The next key milestone is going to be 24 minutes before that. So in about 15 minutes from now, they're going to probably give us an update telling us whether we're trending towards launch or not. And basically what they're going to give us in that update is an update on the wind. So the weather will say, is it good or not? And the health of the vehicle will also be looked at. What is the L-Space NPWEE program? I've never heard of this one. Is it like a rocket competition? Do you like launch rockets, or is it like a written proposal type competition? because it's pretty. I think it's awesome that you get to do that and compete for NASA funding. That's really cool. No one gives us money to build rockets here in Europe like that. Written proposals. Yeah. Okay. Okay. Awesome. Yeah, we right now we're in the midst of trying to raise money, which is like definitely a difficult process, I would say. We have like a crowdfunding campaign that's going, and we're trying to lobby local companies to try to give us free stuff. But yeah, I'm an engineer, so the whole crowdfunding part is kind of like not my favorite aspect, I would say. But yeah, to be honest, uh, building stuff and watching what you build go to flight is a super exciting process, and the opportunity to do that as a student is really exhilarating, I would say. So it's worth all of it. For those just joining, this is where you're here to see the Relativity one. The Relativity launch of the Terran 1, and it's going to be launching at 22:38 EDT, which is in about 35 minutes. That was just announced just a couple minutes ago, so we are trending towards a launch today. There's going to be a couple milestones to watch out for along the way here. Remember, this is a test launch, so there's always a process of figuring out what's going on and making sure the vehicle's healthy, and they'll be very precautious, and there could be some delays along the way, just heads up. But the key milestones where these delays could occur and passing those gates will get us closer to launch. The ones are going to be basically at T minus 24 minutes. They're going to do like a general assessment with weather and launch vehicle, make sure everything's okay. Then at T minus 15, they're going to do the go no go poll. They're going to run through all the systems, the weather, the range, everything, to determine whether they're ready for launch. And then they're going to start preparing like the final preparations of the vehicle. At about T minus 3 minutes, you're going to see the tower that holds up the rocket. It's called the strong back. It's going to like kind of pull back from the vehicle a little bit. Basically, it's letting go of the lines, and it's getting ready to be able to launch the rocket. And then finally, at T minus 70 seconds, that's the last moment in which they can call a hold, and it won't like go to an automatic abort. They might stop it there. They've done that in the past, but they can just continue the clock from there. So don't freak out if it does stop right at T minus 70. And then finally, that'll take us right to the launch. They do have a 3-hour window today, which started just 5 minutes ago. So they could launch the rocket anywhere from 5 minutes ago until I think it's 1 a.m. EDT. So their first attempted time to hit is T minus 0 of 22:38. So we're going to try to see if they're going to be able to trend towards that. I'm not sure if you'll be able to see it from North Carolina. That seems to be a little bit far away, David. So I think you have to be a little bit closer to the Cape to be able to actually see this rocket launch. It's going to be going directly east. So if you were watching like an orbital, a polar launch, so in that case they would maybe launch to the north, then you might be able to pick up that kind of thing. But this rocket is trying to go into a very simple orbit where they're just going to launch straight east, go into a 28.5 degree inclination, which is they take advantage of the most spin that they can from Cape Canaveral with that type of a trajectory. They're basically trying to make this launch as easy as possible so that they can just prove that they can get to orbit and then build on that moving forward. But unfortunately, that means that if you live in the northeast of Florida, you won't actually, I don't think you'll be able to see this one unless you have some serious telescope technology. I don't know. Maybe your backyard has all the toys. Yeah, it looks like the relativity stream has just started, but it's just in the initial uh, initial video part. It's not the people haven't started talking or anything. So we'll switch over when they actually have the full thing booted up, which hopefully shouldn't be that much longer. They're still having their T0 at 2238, it looks like. I don't think they've changed that. Yeah. I kind of like their start screen. It's kind of like the rocket engine. Sorry, not the rocket engine. It's their 3D printer, like slowly printing the a piece, and you just see the little green flash that comes off the nozzle piece. And basically what that is like they're basically melting the aluminum, right? And so it's like the radiation that's coming off that process. It produces a lot of ultraviolet radiation. So if you do actually go into the room where you're 3D printing, like if you go down here, let's see, like this room that they're in here, you see that green like flash that comes off the nozzle there. If you're in the room, like you can get a sunburn from it. That's how strong it is. So they have to like wear all this protective equipment in order to operate near it. Yeah, it's pretty intense stuff. All right. I think they're going to be starting pretty soon here. Let's see. No, they're still in the promo video. Never mind. So, for those coming in relatively in the last couple of minutes, we are still going towards a launch today. The launch is scheduled for 22:38 Eastern time, which is in about 28 minutes. So hopefully that's going to stick this time, but be prepared. It could slip. This is a test launch of this vehicle. It's called the Terran 1. So yeah, be prepared for anything. In the meantime, we are going to switch to the live stream because they've just started up. So you can see there, we have the vehicle sitting there.
Back to round 3. Thank you for joining us again from Cape Canaveral Space Force Station in Florida, where we are ready to launch Terran 1, the world's first 3D printed rocket. Today's flight is named Good Luck, Have Fun, or GLHF for short, and this is Relativity's first launch. We'll be bringing you live coverage from Launch Complex 16, which is our launch pad at Cape Canaveral, as we prepare for historic liftoff. I am Rachelle Aniceto, the Chief of Staff for the Vehicle Architecture and Technology team at Relativity Space. I support our Chief Architect, Kevin Wu, in the design, development, and product management of our medium to heavy lift reusable launch vehicle, Terran R.
And I'm Arwa Tazani Kelly, Technical Program Manager for...
Yeah, I hope that the clear skies are a good sign for the launch. But sometimes clear skies can mean bad upper level winds, so sometimes it can be a bit deceptive from the ground.
Operations on the stages, engines, and propulsion components. Together, we'll be guiding you through our third launch attempt today. Now, if you joined us on March 11th during our second attempt, you know we came very close to launching with 2 aborts during terminal count. Here's a quick breakdown of the reasons for those aborts. During the first abort, we experienced an issue with the stage separation automation system a few seconds before T0 that properly aborted at T-minus 0.5 seconds. Then the team pushed an update to the vehicle automation system, successfully recycled the vehicle, and secured a new T0 time, which was during the last minute of our launch window. After recycling, at T minus 45 seconds, we had an automated abort on the second stage fuel pressure, which was only 1 psi outside of the limit. Let's hear more about our previous attempts from our chief engineer, James Harris.
Yeah, so if they didn't have that separation abort, like they did it 0.05 seconds before they could launch, like, man. If it had...
I'm James Harris. I'm the chief engineer for Terran 1 here at Relativity Space. On our first launch attempt on March 8th, we had a ground system issue that prevented us from getting our liquid oxygen temperatures as cold as we need for launch. So after trying to work through that, we ultimately had to scrub for the day because we couldn't hit what we call our launch commit criteria, or LCCs, on those temperatures. We were able to solve the ground system issue pretty quickly, and we were back out there again on March 11th. And on that day, as you guys know, we lit the engines and got as far down as T minus 0.5 seconds. At T minus 0.5, we check our last set of launch commit criteria. And what happened that time is we tripped a criteria on what was calculated as a leak rate. We were able to find the cause of that in the automation and fix it quickly and turn around into another attempt. The second attempt aborted because our fuel tank on stage 2 was slightly outside of pressure bounds. And again, that's something that we can very easily fix. We've really learned a lot from these first 2 launch attempts. We've really nailed down our ConOps and the flow of how the operations day goes, so it's pretty smooth now. In the second attempt, we had really excellent propellant temperatures and we're well conditioned and ready to fly from that point of view. We also got a really important data set of running all the way through our countdown down to T0, including lighting the engines. Getting that data set lets us then check all of our other abort criteria to make sure we weren't going to hit anything else. And what we found is that the only issue we had on the March 11th attempt was that one pressure decay red line, which we were able to fix by changing the valve close timing. So that data set really gives us the confidence that we have our automation and our abort criteria ready for the next launch attempt. I'm really excited to go into the next launch attempt. I think we got the last couple pieces of data that we needed to make sure that the next attempt here is going to be successful, and all of our automation and abort criteria are going to get us there to a successful release.
This is big, guys. Like, they've really collected a lot of data to get them to the point where they're basically ready to go. So that's good to see. Although it does look like we have a hold here at T minus 25 minutes. So they're probably not continuing for 22:38.
Update here. We are, as you see, holding the clock at T minus 25 minutes. Our launch time right now is delayed due to 2 reasons. So we had the upper level wind shear being outside of stage 1 gimbal limits. However, the latest balloon data did show that it is now within acceptable limits. So we'll be keeping a close eye on that, and we'll hold the clock as necessary if needed closer to launch. However, now there is currently a boat in the range, so we are holding the clock
not the
and
boat
waiting
again.
for the range
Come
to
on.
clear that boat out of the hazard zone. We'll keep a close eye on it and give you an update shortly here once we know what happened.
How are boats always coming into these launches? Like, seriously. This is insane. I feel like it happens every time. So there's supposed to be an exclusion zone for a rocket, like basically like an area of the ocean that is in front of where the rocket is launching, where you're not allowed to like just sail a boat for the time of the launch. But for some reason, these range areas always get violated. But the funny thing is, it's always in Cape Canaveral. That's where the boats are always an issue. Like anywhere else in the world, usually the boats are not such a big deal. I feel like there's like a Florida resident joke there. Maybe it's like one of the competitors to Relativity. They just keep sending boats. Block them, don't let them launch. Oh, man. In terms of the other condition that they were looking at, which could block the launch, which was the upper level wind shear, they're talking about it being outside of the gimbal limits of the core stage. And you might wonder, like, what does that mean, really? Well, basically, if the winds in the upper atmosphere are high enough, they create a force on the body of the vehicle, because the rocket's like going upwards and the wind is coming to the side. So it like basically, instead of the force of the wind as the rocket's ascending being like straight down the length of the vehicle, it then starts coming a bit to the side. And that'll basically destabilize the rocket and start like pushing it over. So the engine has to gimbal or push a little bit to the side, and you'll see it gimbaling at the start of the launch because it does a little test before it launches. The engine has to push to the side in order to counteract that transverse force. And if the wind is high enough, like it can be outside of the limits of what the engine can actually achieve. So that's why they will sometimes delay or cancel a launch due to upper level winds. But it looks like that's not the problem here today. It's actually just the stupid boat. I feel like there should be heavy fines for sailing a boat into the range violation area. Like, Florida, come on. What's going on? In the meantime, we can see that the rocket is still getting fueled nicely.
Just as a reminder, we are holding the clock at T-minus 25 minutes due to a boat being in our hazard zone. We're holding until the range clears that boat so we get that green.
It really shouldn't take too long to clear the boat though, because usually like they'll send out somebody to yell at them. Yeah, like considering how much money it takes to actually set up a launch, like it'll sometimes cost like for like setting up the range and getting the people there and, you know, fueling up the vehicle and everything. Like you're looking at hundreds of thousands of dollars just to get a rocket to launch, like just to do one launch attempt on a day. So if it's really a boat that is actually disturbing that process, like theoretically that boat's liable for like hundreds of thousands of dollars of damages. So I don't know. There definitely should be some sort of mechanism by which you can sue the boat owner. But I'm not sure what the laws are around this. Yeah. Like just the cost for the fuel in this vehicle alone is probably near like close to $100,000. So if they have to scrub because of it, they have to basically get rid of all that fuel. And that's money that you lose, right? But we can see right now that they're not scrubbing yet because you still see the clouds coming off the vehicle. Those clouds are basically what happens when the rocket is venting a little bit of gaseous oxygen, and it does that because the rocket is fueling, so it's taking in liquid oxygen. But that liquid oxygen is like really, really cold, like minus 190 degrees Celsius. And Florida is warm, so the liquid oxygen is slowly vaporizing and increasing the pressure inside of the tank. So to keep the pressure within limits, they have to let some of it go, and that creates a bunch of condensation where they do that, and basically you see those clouds. So it's an indication that they're still actively fueling the vehicle if you see that. You'll also see on the right hand corner there's a flare tower. It's the big fire on the bottom of the screen. That is kind of the same thing, but instead of it being the oxygen, it's the methane. Because remember, the fuel is also cryogenic. So they're doing the same thing with the methane tank as well. It has to let go of some methane in order to keep the tank pressurized at the right nominal levels. But the problem with methane is you can't just let that into the air, because now you're letting methane and liquid oxygen into the air in the same places. Like that's a huge explosion risk. So they have to flare that kind of further away from the actual site of the launch site. So that's why they have like a special pipe that goes all the way over to that flare tower and flares off that excess methane, so that you don't have any fuel just sticking around near the rocket, creating an explosion risk. Yeah, and all of those things indicate that they're still actively fueling the vehicle and still trying to get ready to launch. So even though we have this hold, we can still, we'll probably still see a launch today. They just need to get that boat out of the way. The last time they had a boat violation in the first launch attempt, they cleared it in like 5 minutes. So hopefully it's still the same in this case. I kind of wonder what kind of boats are actually causing these issues. Like, is it like a commercial ship? Because if so, then that's like pretty strange that they wouldn't know about the restrictions that are there around Cape Canaveral. I kind of suspect they're actually all private boats that violate these ranges, because I feel like they would have less information about the actual area that's supposed to be dedicated to just the rocket exclusion zone. There's a 90% chance they won't launch when they're calling holds. I don't know if that's totally the case, because like I think for a classic, for a launcher that's, you know, well established, yeah, once they start calling holds, it's basically a no-go. But for this test launch, I don't know. Like, I think they're going to call lots of holds throughout this entire process, just because it's the first launch, you know. But yeah, I don't know. Maybe. I'm still holding to my 60% chance this launches today. 60-40. It just might take some time. Which maybe isn't the best for me, because it's already like 3:30 in the morning here. I would like it to just launch, my goodness. Unfortunately, it's going to be a night launch. I would have preferred the daylight.
Holding the clock at T-minus 25 minutes for a boat in the hazard zone that we're waiting for the range to clear. While you're waiting here, I know that you see a big ball of fire next to our vehicle. I just wanted to tell you all that not to worry, that is on purpose. That's just our flare stack, and it's used to vent flammable gases from prop loading and venting operations and priming of the engine igniters. We're going to continue to hold until we have that update from the range.
So yeah, again, the hold is not for a technical issue, so I don't think this is really affecting the chances that we'll have a launch today, but annoying because it's blocking out the first hour of the launch window. But okay. I don't think it's tourists that are blocking the range. I think it's local Florida residents in their private boats just sailing around, going wherever the hell they want. In classic American form. But oh well, I guess. The consequences of being a free country. Yeah, hopefully, like, they are taking a little while to actually clear this issue, though. More than I would have expected. That's a bit disappointing. One thing that I can tell you that maybe is a bit interesting about this rocket. So they were talking about the flare stack there in the last update. Basically, that's that ball of fire that's on the lower part of the screen. Maybe they'll switch to it here. I think I'm in the way of it right now. Where am I here? No. In one of the views they have the flare stack. But the reason why they have that is because they're flaring the methane. But this actually creates a problem because the methane is not really 100% methane. There's like little bits of propane and ethane inside of the methane that they put into the tank. And so as they fill it and hold it in the tank and slowly let some methane that boils off go, it's only the methane that boils off. The propane and the ethane don't really. They kind of settle to the bottom of the tank. And so there's slowly more and more and more concentration of ethane and propane in the tank. And it gets to the point where there's actually too much and it can create a problem for the engines. So they can't actually fuel the methane so long, otherwise they have an issue with propellant composition. So usually when you're working with methane, it doesn't really favor long periods of time where you have the long fueling process. What are these lights? What the heck are those lights? Those must be on there's like 4 rods that are going up on either side of the rockets. And I've never seen those lights turn on before, but I guess it hasn't been night before, so maybe they have been going on and I just didn't notice. Yeah, unfortunately, I do have to work tomorrow. But hey, sleep is for the sleep is for those who are not excited about rockets. I'm hoping I get a couple of hours before I have to start my day tomorrow. We'll see. I'm not sure whose job it is to clear the boats. I think it is like the job of the launch site. So I think they have to like either it's either that they just radio the boat, they try to like raise them on the radio and say like, hey, get out of the zone. Otherwise, I think they might have to actually go and intercept the boat and like tell them to leave. I'm not exactly sure how that works. Yeah, if they have to intercept, that would be insane. Yeah, so the lights on the post are for planes. Oh, well, if that's the case, I don't know, because like if there's planes flying around in that area, like the boats aren't allowed. Surely the planes are not allowed. Yeah, I would also like to see, like, if they maybe they do send a helicopter. That actually would make more sense. Like they have a little chase helicopter that goes and says, "Get out of here." Yeah, they should live stream that once. Live stream them giving them the bill for disturbing the range. Here's your $100,000 bill. Don't come again. Okay, so it is a helicopter. Yeah. Oh man. Yeah, that's I guess sometimes that takes a little bit of time. I assume you're asking how big the company Relativity is. They are actually a fairly large company at this point. They have hundreds of employees working for them. What is bigger though is how much money they have in the bank. So they've raised like $1.6 billion over the course of the last couple of years. So they are like liquid. They have no financial issues. They're probably the most secure financial rocket company in America, other than SpaceX. So, yeah. Probably the most secure financial company in the world, actually, other than SpaceX. Like even maybe more than like than Rocket Lab and stuff. Like seriously, they have a lot of money. Yeah, maybe Rocket Lab. I don't know. It's a toss up. Rocket Lab is definitely, like, they've definitely progressed a lot and they got lots of launch history. But like seriously, the technology that Relativity has is far more valuable, just from a basic standpoint. And I don't think Rocket Lab has as much like investment backing behind them and investor confidence. Like they raised 1.6. Think about it. Relativity has raised 1.6 billion before they've even launched a rocket. Like that is truly unprecedented. Yeah, Blue Origin doesn't count though. They have like a billionaire backing them fully all the way. I feel like that's kind of a, yeah. I mean, yeah, okay. Maybe Blue Origin is the healthiest because it'll never fail. Jeff Bezos is too rich for it to fail. But I feel like Blue Origin isn't really competing, like in the commercial rocketry industry in the same way that the other companies are. Like they're kind of just, so far they've just done suborbital launches, and they've done it for tourist reasons. That's kind of not really the same space. Yeah, maybe they have their own. Yeah, does the company have to mobilize the helicopter themselves, or is it like the range that has to mobilize the helicopter? This I don't know. So I don't think Relativity has their own helicopter. That seems like a much richer kind of company thing to have. I think that the helicopter should belong, like it would belong to the range, and then the range goes and deals with this issue. There has to be a lot of range cooperation to pull off a launch. Like, it's not just the company that is responsible for the launch. It's also like, it's like a combined effort where it's both the range and the company. So the range has its responsibilities and the company has its responsibilities. And usually they usually have those separate roles. I believe they would be operating with NASA's help because they're operating out of Cape Canaveral right now. So that's NASA's land. So I think NASA is the operator of the range. If they're launching from a Space Force area, then it's different. Then it's Space Force that is operating the range. But in this case, I don't think that's the case. That's only for like the launches in California.
We are currently coordinating with the range for a new T0. We expect to get that new time in the next 5 minutes, so we are currently standing by.
Okay, so it looks like they have managed to clear the boat. We just have to get our new T0, which will hopefully be not cycling back all the way to 40 minutes. Maybe they can just start up again from T-minus 25. We'll see. There's not really any steps that they would have missed. Yeah. It kind of looks pretty cool with those lights flashing there and the rocket. It just looks way more like launch imminent. They should have them flashing with the countdown. That would be cool. They got to think of like the cinematic nature of the launch too, you know. Yeah, definitely cinematic. Especially in the night. They could add some production value to their live stream. But I suspect that they only do that when the helicopter's out intercepting the boat. So for anyone who has joined recently, we're here with the Terran 1 launch from Relativity Space. This is their Pathfinder vehicle. So this is the first launch of this particular vehicle. It's special because it's 100% 3D printed. So the entire structure of what you're seeing there is, sorry, did I say 100% 3D printed? I meant to say 85% 3D printed. The entire structure that you see there is all been 3D printed on their special machine.
Announcement on countdown. We have coordinated new T0 time and are currently targeting 03:05:00. The clock will resume in approximately 5 minutes.
Okay, I think that is set up for 30 minutes from now.
As you heard on countdown, we are targeting a new T0 time that we have now confirmed with the range at 23:05. Again, that's 23:05 Eastern. The clock will resume shortly according to that launch time.
So that's going to be in 30 minutes. Yeah, the launch sites tend to use UTC. They don't use the Eastern Standard Time. That's just a general protocol. They do that a lot at other launch sites as well. It's just it can be very confusing with times between different launch sites and different time zones, and whether the time zone is doing daylight savings or not. And you can also have, like, there's a lot of cases these days where the actual like the control room is actually not at the launch site, so it's in a different time zone. So it's just easier for everyone if you just use one standard time. So UTC usually works for everyone, and it just makes everyone's life a lot easier. Yeah. You don't want to have a situation where somebody thinks it's supposed to launch now and someone else thinks not, because then you have problems. I'm sure this has been an issue in the past. Yeah, whenever I'm like getting ready to watch a launch, I'm always, checking it in the UTC, usually anyway. So yeah, just a quick update. We are trending towards a launch again. The clock does say hold right now, but it will resume in 3 minutes. We have a new T0 time, which is going to be at 23:05 Eastern time. So that's going to be in about 27 minutes. Yeah. Vehicle looks healthy. We don't see any issues. They have worked through a lot of the technical issues in the last launch attempts. They've addressed all of them. They also got a lot of data in those launch attempts with, thinking about their launch criteria and what they should expect when the engines ignite, because they did ignite last time. They stopped it like right before they let the launch clamps actually let the vehicle go. So it's like a last minute abort. So I do expect this to be a successful launch. We'll see. Yeah, we should see things picking up here in just a second. The next thing to look out for, basically, once the clock resumes, it's going to, we're basically past the 25 minutes hold point, which was the first gate that I was talking about before. The next gate that we're going to be pushing towards is the T-minus 15 minutes, which is where we're going to see the go, no-go poll. And that's where they're going to go through all of the different systems of the rockets, also the range and the weather and the launch coordinator. And they're going to decide whether they're go or no go. If there's anyone who says no go in that point, then they're also going to put the clock into a hold. But if they get past that, then it's definitely looking good. Anytime we should see this clock starting up. Hopefully we're not pushing into a different hold. It should be starting up in the next couple of seconds here. We just have to be patient. Here we go. We've started up. We're moving towards the launch again. That makes me happy.
All right, the clock is rolling. We are just under T-minus 25 minutes now. We did receive confirmation that propellant loading is complete for both stages. We're going to keep an eye out on those upper level winds and on the range today, but the vehicle is healthy. So as of now, we're proceeding with 23:05.
Thank you, Arwa. Arwa will continue to provide regular status updates over the course of the countdown. In the top left of your screen, you can continue to find our countdown clock to follow along in our pre-launch operations.
And now a quick reminder about the purpose of Good Luck Have Fun. This is a first launch, meaning that while we're aiming for Terran 1 to reach orbit, our primary focus is on gathering the data and learnings necessary to develop Terran R, our much larger, medium to heavy lift, reusable launch vehicle. The lessons learned from this mission will also enable us to improve our software-driven approach to manufacturing.
And as a reminder, today's launch includes many firsts. Terran 1 is the first 3D printed rocket, which is 85% 3D printed by mass. It's in a race to become the first Methalox propelled rocket to achieve orbit. If orbit is achieved, Relativity will also become the first venture-backed space company to have successfully reached orbit on its first flight.
And it's worth noting that while Terran 1 will be capable of lifting 1,250 kilograms into low Earth orbit, or LEO, today's launch doesn't have a customer payload. We do, however, have a memento aboard, one that's quite unique to Relativity that we'll tell you more about later.
Liftoff is currently scheduled about 22 minutes from now. This estimation may change as we continue to work through our countdown, but we will keep you updated along the way. Today's launch window lasts for 3 hours, and this provides us more time to troubleshoot any issues that could arise. And if any unforeseen issues arise during the countdown, we can pause the launch sequence if necessary, as you've just seen.
The window for today's launch attempt opened up at 2200 Eastern Time. The pad was cleared of all personnel at T-minus 4 hours, followed by the start of propellant loading, which has since been completed. We're now topping off our tanks and conditioning our propellant to the proper temperatures ahead of launch. Now at approximately T-minus 20 to T-minus 15 minutes, the launch director will poll the launch teams to ensure that all subsystems, weather, and the range are go.
This will be a key milestone.
Terminal count will then begin at T-minus 70 seconds, and that's when the vehicle's internal flight computer will take control of the countdown. Now while we wait for T0, let's talk about the process that got us here.
Good luck, have fun is the maiden launch of our 3D printed Terran 1 rocket. Terran 1 is an orbital class rocket, so reaching orbit would be the best possible outcome. But as you've heard us say before, we are truly looking for some important base hits here today. Notably, a key objective for today's flight is largely about proving our hypothesis that 3D printing is a viable way to manufacture a rocket and it can successfully withstand the pressures of flight. Through robust ground testing, we're confident that we have a real shot at proving just that. So the more data that we collect from this flight means that we'll have access to more insights, and this will give us the confidence that we're able to execute on Terran R and help us solve all the hard problems that come with building a medium to heavy lift reusable
Terran
rocket.
R is the future.
As a business, we're following
It
a
should be fully
Pathfinder
reusable.
product development approach. So the Terran 1 that you see on the pad today has always been our Pathfinder. It was designed to be a development platform for Terran R, and it has served us exceedingly well to date in that capacity as we progress through printing and testing ahead of today's launch. Arwa, let's remind everyone what we would call a success for today's launch.
Absolutely.
Getting
Again,
off the pad without
safely
exploding.
clearing the pad, getting out over the ocean, and passing the point of maximum dynamic pressure, or max Q, would be a big milestone for today's launch. This is again because it's the point where the structural loads on the vehicle are the highest, making it one of the most challenging phases of flight. And this is the point in flight where we really want to prove much of what has already been proven on the ground. During acceptance testing, the vehicle withstood loads even beyond what we anticipate it will encounter.
So
during
the
flight.
material is
passing
3D
this
printed
milestone
aluminum.
would effectively
It's a
demonstrate
special
that 3D
alloy
printed
that they've
rockets
developed
are
themselves so that they can
structurally
actually do
viable.
this.
And then
It's
if we
basically, it
move
rolls
further
out like
to
plastic
smoke
filament.
separation,
It's
we will
just
have achieved
metal
a
instead.
full first stage flight, and that'll be
so
another big accomplishment.
It's very special because of
From there, we'll
its
attempt
ability
to
to
light
be
the
3D
second
printed in
stage
this
and
manner.
get Terran 1 to orbit.
This rocket is not
Stage 2 is
reusable,
targeting a
but the Terran
200
R, which is for the
kilometer
future,
by
that's the
210
one that they're
kilometer
planning to be
orbit.
reusable.
And this is not a traditional orbital target.
And trust
But
me,
that is our
yes,
target
it
for
will be
today,
very
and
valuable
this is our
IP.
first
Like this
launch and
is,
not a customer mission. As a reminder,
it will be
we
a
don't
force
have
in the
a
future,
customer
I assure
payload
you.
on this flight, since it's not a customer mission.
There's a reason
So
why
instead,
it's
we are
the
celebrating how far
like
we've come
one of the
by
most
mounting our first
heavily
ever
funded
metal 3D print from the first generation
like
Stargate
pre-IPO,
inside a
pre-launch
Terran
rocket companies like ever.
Of course, it was a failed
Over $1
print
billion
since no one had done it
raised.
before. Let's go ahead and take a look at this memento. So that piece that you're seeing there is about 6.5 inches in diameter and weighs about 3.3 pounds.
This is the payload
That is our
today.
first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with the GLHF and our mitosis logo to commemorate this maiden launch. We would be excited to see this memento get to orbit. But to take a step back and set expectations, we want to note that we are unsure how much of the second stage flight we will be able to share with you live. While we do have cameras on board, we will be prioritizing vehicle telemetry sensor data for this launch in order to maximize our learnings, and as a result, the video connection could be spotty. In the event that we do lose video, we will do our best to keep you up to date as we receive telemetry and information live.
And once again, we have strict safety protocols in effect for today's flight and are of course closely coordinating with the FAA and Space Launch Delta 45. These protocols are standard for all launches and ensure that no one would be in harm's way if there were to be.
Just don't get freaked out if the camera on board loses footage or something like that. Like they were saying, they are prioritizing the engineering data. So listen for the callouts as to whether the vehicle has reached milestones successfully, as opposed to going off of what you see visually. Especially in the later phases of the flight, that's going to be really important.
Humanity, a multi-planetary species. Now, as a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger, medium to heavy lift reusable launch vehicle.
Up next in our countdown will be the go, no-go for launch.
If you're watching from your
which is
backyard,
expected to
then
occur
I
in the
envy
next several
your
minutes.
location.
Let's take in some views of Turn 1 under the lights of Launch Complex 16 while we wait to hear from Mission Control.
Yeah, the backyard is definitely the place to see the rocket. I would love to live close to a launch site. That would be like definitely an improvement on where I live right now. No rockets really launched from Europe, unfortunately. How can you send me a video? I don't know. I suppose you could email it to me. The ASTRA, yeah, I don't know what our email is. I think it's astra-brayman@gmail.com or something. That's the YouTube email. I think if you just email it to that, it'll work. Yeah, so all the steam that's coming off the rocket is from the gaseous oxygen that is basically being released by the vehicle. You have to think about this. The oxygen is being stored at minus 190 degrees Celsius. So as the air in the ambient environment is going to be heating that up slowly, and that means that some of the oxygen is going to vaporize, and that will cause the tank to become too pressurized, so it gets higher and higher pressure. So they have to let go of a little bit of that gaseous oxygen back into the environment. And when they do that, it basically causes a whole bunch of water to condense out of the air, and that's how you get that cloud. ESA launches all their rockets from Kourou, which is a launch site in French Guiana, which is down in South America. So yeah, they don't have any launch sites for the ESA launches in Europe itself. They do have a launch site in Kazakhstan, but that doesn't really count as Europe. And also, they don't really launch from there anymore for obvious political reasons. So we're just waiting in on their go, no-go poll, which should be coming up probably pretty imminently. It's usually around T-minus 15 minutes. So we will hear their ground control basically just go through all the callouts here.
Once again, everyone, we are currently standing by for the go, no-go polls from Mission Control. This should occur in the next several minutes.
They're taking a bit longer to do this than they did last time. Yeah, it's tough to launch from Europe because in order to have a launch site work really well, you kind of have to have water to the east. And Europe isn't really situated where they have like ocean to the east, unfortunately. They have a lot of ocean to the west, but that's kind of the wrong way if you want to launch a rocket, because then you have to fight the rotation of the Earth, and so your rocket needs more energy in order to take off. It's also fine if you have like a big open area where no one lives, but Europe is pretty densely populated, so you don't really have a lot of places like that. You do in Russia, which is why they have the Cosmodrome in Baikonur, but again, obviously Europe's in a bit of a war with Russia right now, so that launch site is not really in the cards right now. It would be cool to see a launch site open up in like Spain or Italy or something, because they do have water that goes to the east in the Mediterranean Ocean, and those could actually be interesting places to launch rockets. But unfortunately, Spain and yeah, there are launch sites in Australia, but it's tough to get rockets all the way to Australia. Like if you think about it.
Down this LD,
Oh, here we go.
we are going to pause the clock T-minus 10 minutes to assess high-level winds. We'll
Shit.
update briefly with a new T0 time once we get new balloon data.
Damn it. So it looks like the upper level winds are causing their issues again.
All right, as you heard from our launch director, Clay Walker, we are going to hold the clock at T-minus 10 minutes. We're currently evaluating those upper level winds and just make sure that the wind shear is okay with our stage 1 gimbal limits. We're going to coordinate with the range and make sure we have the proper data that is within acceptable limits before we have a new T0. Stand by.
So yeah, it looks like the upper level winds are getting the better of us again. And the way they're assessing this is basically they send a bunch of weather balloons up into the upper atmosphere, and they use the data that they get from them. It's basically a live feed that they have on that data, and they use that information in order to determine, first of all, if they are okay to launch, and then they can actually do some projection to see where they might have a good launch in the future. So it's kind of like a complex weather assessment system that they have going on there. But yeah, unfortunately, it looks like we're once again going to have some issues with the wind. Just a reminder, the reason why the wind is such a problem sometimes is because basically there's a shear on the rocket when you're up in the higher altitude. So you have the velocity of the wind coming in from the side, and you have the velocity of the airstream caused by the rocket's motion, which is going like straight up and down towards the vehicle. And so because you have this shear caused by those two vectors of the winds on the rocket, there's actually some forces on the rocket that are pushing it to the side.
We are currently looking at an updated launch time of 23:25 Eastern. That's 11:25 p.m. Eastern. We're going to wait for that final confirmation from the range, and then we'll pick up our T-clock accordingly at 23:15.
So it looks like they're cycling back to T-minus 20 minutes, most likely. That's where 23:15 is in the countdown. So we're going to lose 10 minutes because of this wind issue. So it looks like they're projecting that the wind will get better moving forward. Yeah, don't say that it's a no-go yet for today. Yeah, so the upper level thing is a problem at around 10 kilometers in altitude. So it's the winds, the jet streams that are up in the stratosphere. That's what we're talking about when we say upper level winds. That's basically exactly right around the point where the rocket is hitting max Q, which is why it's so critical in that phase. It's also the case that when they hit max Q, the rocket isn't like totally moving at a super fast speed at that point. So that vector of the jet stream coming in is actually significant, because the rocket is like just passing the speed of sound. But those upper level winds can be going like sometimes in the range of like, 0.2, 0.3 of the speed of sound. So like if you do the vector calculation, like it's a significant percentage of the actual speed of the rocket, which is why those engines have to gimbal in order to counteract that transverse force caused by the wind. And if the wind is too high, it basically it oversaturates the rocket's ability to compensate, and then you try to make sure that you don't launch in those conditions, because you could have the vehicle actually break up because of structural reasons. Yeah, in terms of where it is in the prior or post max Q location, it's roughly right around max Q. Like that's where it's most critical.
As we continue to hold, let's take a moment for those that missed the previous broadcast to do a refresher about the Terran 1 architecture. Let's go ahead and look at Terran 1 on a graphic up on the screen.
So this is
So
actually a pretty
starting from
good
the
graphic we
left-hand
use
side
here.
of the vehicle, this is the bottom where we have the 9 Aeon 1 engines. In our previous broadcast, we talked about these engines getting printed using powder bed fusion or PBF technology. Each of these engines has a thrust capability of 23,000 pounds at sea level. This gives us a max total liftoff thrust of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and we have thrust vector control actuators, or TVCAs, mounted on these engines in order to gimbal the vehicle during flight. We have completed more than 2,000 engine hot fires and over 10,900 seconds of runtime across Aeon 1 hot fire tests. The Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the load from the thrust of the engines. And above the thrust structure is the stage with WAM printed tanks. This is our wire arc additive manufacturing in-house process. These tanks hold liquid oxygen on the top and liquid natural gas on the bottom.
The WAM.
These tanks are pressurized during flight using an autogenous pressurization system. This works by running propellant through heat exchangers mounted on our engines, which convert the liquid propellant into a gaseous state, and this is piped into the top of the tanks to maintain our ullage pressure, or the required pressure for the tanks. Above the Stage 1 tanks is the WAM printed interstage, and this holds our stage separation mechanisms that separate Stage 2 from Stage 1 during flight. This is a pneumatic pusher system. And above the interstage is Stage 2, which has a single Aeon vacuum engine that is also printed with PBF.
It's pretty cool to use pneumatics to
This
separate.
engine has a thrust capability of more than 25,000 pounds in vacuum and has...
Announcement on countdown, this is the LD. We have coordinated a new UTC target time of 03:25:00. Clock will jump back to T-minus 16 minutes for go, no, go poll. And we'll begin count shortly thereafter.
So this sounds good.
Okay, there was that official confirmation of the new launch time of 23:25 Eastern. We are going to roll back the clock shortly to T-minus 16 minutes so we can go ahead and resume our go, no-go polling with our team of engineers and mission control, and we'll do that in alignment with 23:25.
So that's in 26 minutes. So they're not going to start the clock for about 10 minutes.
And as we continue to wait, let's finish up on the Terran 1 architecture. As I mentioned, Stage 2 has WAM printed tanks just like Stage 1. And above Stage 2 is the WAM printed nose cone. So for future missions, this would be replaced with a fairing and also have a separation system. We don't have a customer payload as we discussed, but we did design Terran 1 for a payload capacity of 1,250 kilograms to low Earth orbit, or LEO, and 900 kilograms to Sun synchronous orbit, or SSO, for customer missions. All data from Terran 1 development will be fed into Terran R, and you can follow along our updates in the development, particularly for our Aeon R engine. We'll go ahead and take a moment to continue to look at Terran 1 out on the pad as we wait for updates from mission control.
All right, so we're cycling back to a launch. I think it's going to be at 11:25 Eastern time. So that's just in about 24 minutes. So they're going to start that clock back up again in about 8 minutes. There are a couple of little details that they mentioned in that overview of the vehicle that are actually kind of interesting. The first one being that they're actually using autogenous pressurization in order to pressurize these tanks. Typically in rocketry, you will use like a separate pressurant in order to pressurize your tank. And the reason why you pressurize the tank is because the turbines and the pumps in the rocket actually need to have pressure in order to like suck in the liquid. If they don't, it can result in what's called cavitation, where essentially little air bubbles get into the fuel and the oxidizer, and those bubbles can basically cause a lot of damage to the turbines inside of the pumps. So they want to avoid that as much as possible. So they'll use a pressurant. But if you use autogenous pressurization, that means that instead of using a pressurant gas, or like helium or nitrogen or something, they will actually use the actual gas of the propellant itself. So instead of like having helium come in and pressurize the methane tank, they'll use the methane gas that's like evaporating in the methane tank to pressurize. And that kind of helps them save on mass and also complexity. Yeah, hopefully the boat stays out of the way for sure. We'll see. Oh, that's too bad that the fog rolled in. Man, that sucks. Yeah, at least you still have the broadcast. That's still, I guess, positive. But yeah, it would have been nice to see the launch from your house. From South Carolina, it would have been tough though, to be honest, because again, this rocket is launching to the east, so it's not going into a much of an inclined orbit. It's just going to go to the standard 28.5 degree inclination, which means the rocket will go straight east from Florida. So I'm not sure if you can usually see rocket launches that far south of you. But I don't know. I've never been to South Carolina, so maybe you are close enough to be able to see the launch. I guess in the night you would see like basically a little bit of a flame if once it got high enough into the sky. Yeah, so basically the pressure is generated like while they're just on the pad there. The pressure is generated just by the vapor pressure of the working fluid, being both the methane and the liquid oxygen. So both of them are using this method. Once the engines start up,
As a reminder, we have coordinated a new T0 time of 23:25 Eastern. The T clock is currently paused at T minus 16 minutes. We're going to resume that T clock in about 5 minutes, where we're going to go straight into the go no-go polls with mission control.
Yeah, in terms of once the rocket is actually flying, the methane system works like that. So they're going to take the working fluid. It goes through the microchannel coolings in the engine and in the combustion chamber, and they use that gas, a little bit of that gas that comes off that, to continue pressurizing the methane tank. They can't do that with the oxygen tank because they don't send oxidizer to the nozzle for obvious reasons. If there's one little leak, it's bye-bye rocket engine if you do that. So I'm not really sure exactly how they continue pressurizing the liquid oxygen tank. I suspect they do actually use external pressurization. So they might have some helium on board to just pressurize the oxidizer tank. Yeah, the no-go poll, go no-go, is going to come in about 4 minutes. So stay tuned. Hopefully it'll be a more successful one than the last one. Yeah, the mosquitoes are, I guess, are coming out. Are they coming so early? Like it's only March. Seems a bit early for mosquitoes. One nice thing about Bremen in Germany is that we don't really get mosquitoes. It's too cold for them here. Man, a lot of you guys are watching from the backyard. I'm a little bit jealous. Man, that sucks. Mosquitoes year round? My goodness. I don't know if I could take that. The mosquito repellent industry must be booming there. So, it looks like everything is still going well. We will have the go no-go poll in, it looks like, just 2 or 3 minutes here. So that's the point where we'll see a resume to the clock. And hopefully we'll finally get past the next barrier, which is the go, no go pole. And that will push us into the more operational stages of the launch. Basically, the rocket is going to finish up its fueling process. It's going to start doing some like pre-flight checks. That's going to happen a little bit closer to the T-minus 5 minutes and before. So you'll see the engines do a little gimbal test. You'll see the strong back, which is the tower that's supporting the rocket. You'll see that thing kind of pull away because the fueling is no longer happening. And generally the rocket will be cycling towards the launch. Yeah, I personally like the twilight launches the best because there's like a really cool effect where when the rocket gets up into the upper atmosphere, the sun is still like shining and at those levels, and the sun will basically reflect off of the rocket plume, and it just makes these like gorgeous vapor plumes in the sky that are like, they're just like so just perfect. You really get to see the technicality and the display of what's happening in kind of a grandiose scale. And it kind of looks like the aliens are landing, so that's kind of cool too. Yeah, so the condensation on the rocket is actually ice. And the reason why that's the case is because the rocket is really cold. Like really, really cold. It's the liquid oxygen and liquid methane are being stored at minus 190 degrees. So water condenses on the body of the rocket and freezes. But basically when the rocket launches, all that ice is going to fall off. And that's just a consequence of working with cryogenic propellants.
All right, T-clock
here we
is
go.
rolling. We are less than 16 minutes away.
So we should be close to the go, no go pole. They should be giving that to us pretty quickly. Yeah, the twilight launches do freak out.
This is the go, no go pole.
Okay, here we go. Listen in.
Launch. Please provide concurrence to proceed in the launch countdown with go, no go.
They're gonna.
GC.
Yeah,
GC go.
here we go.
GC1. GC1 go. GC2. GC2 go. Ground. Ground go. AVI. AVI go. FTS. FTS go. RF. RF go. GNC. GNC go. Flight software. Flight software go. Thermal. Thermal go. Prop 1. Prop 1 go. Prop 2. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 2. Fluids 2 go. Loads. Loads is go. Rock. Ranges go. OSM. RC. RC go. Vehicle. Vehicle is go. CE. CE is go. LC. LC is go. All parties have reported go for launch countdown. Once
That's
the
a go,
clock starts
guys.
to roll, anyone can call for a hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort. Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
Yeah, the wiggling is all part of the process.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Let's take a moment to introduce you to our Mission Control team. Clay Walker, who you just heard, Launch Director. John Wiswall, Launch Conductor. James Harris, Chief Engineer. Elijah Escobedo, Vehicle Controls. Brian Batters and Zoe Dickard on Ground Control. Bill Stack, Ground. And Joy Mosdell, Range Coordinator. These are a few notable members
So
also from
the vehicle is a
leadership are
go.
supporting today's launch here
We're now
at
going to be
Launch
cycling
Control, and
towards
this includes our
T
co-founder
minus
and
70
CEO,
seconds.
Tim Ellis, our
That's
Chief
going to be the
Operating
next key
Officer, who
gate.
leads
Once they
product
get past that,
execution
then the
and
vehicle
depth,
is in terminal
Vice
count.
President of Test
And if
Launch,
they
John
call a hold at that
Patterbeck,
point,
and
then
Director
it
of
goes
Fleet
straight to an abort.
Operations, Pat
So
Swantek. These are
uh,
among the
that's the
many,
point
many
where
others who
basically
are
the
making
computers take over.
today's launch happen. Let's go ahead and take a moment to pause and listen in for any other updates from Mission Control.
Yeah. The key activity will start to happen
I
at
think
about T minus
while
5
we
minutes.
wait, maybe for our new viewers, let's give them a little bit more info about the systems that we're seeing on the pad once again. So the rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. That's the black vertical truss structure that you see behind the rocket there. The 4 large towers surrounding the pad make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, you'll see 4 small black posts around the pad called rainbirds. They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics at liftoff. The small flame that you see there at the bottom right hand of your screen was once again the flare stack. No need to worry, this is perfectly intentional. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see, but the small slide-looking structure beneath the vehicle is our water-cooled flame diverter.
Yeah,
It's
this
used
thing
to
right here.
mitigate the heat from lighting the engines, and it directs exhaust plumes away from the vehicle. You might also be able to see in this view 3 different levels under the rocket. So the largest and lowest level is the pad deck, and directly above it is the launch table. So this is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. So it transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system or hold downs and the quick disconnect or QD carriages that provide propellant and other commodities to the vehicle when it's on the ground. I do once again want to give a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate.
Yeah, pretty much everyone uses the flame diverters and the water deluge system. It's just what's required in order to dampen the sound of a rocket launch. Without those things, you're basically gonna shake your rocket apart. Like literally, like you will literally shake the rocket apart. The sound and the vibrations that come off of a rocket at launch.
We did just
are-
get an update that, according to our latest weather balloon data, upper level winds are currently go. So the T clock is going to continue to roll.
Countdown sequence has started.
There you go. We are just 10 minutes away from this historic launch.
All right, so hopefully weather will not be a problem. They're going to keep checking with that balloon, though. They basically do that all the way up to about 5 or so minutes. But I think that the weather was trending in a good direction, so that shouldn't bother us anymore.
Filling propellant supply targets.
Now we get
We're
into the
currently at
nitty-gritty.
T minus 9 minutes and 20 seconds. Now in the next few minutes until launch, you'll hear callouts from our engineers and mission control as we go through the final procedural steps before liftoff. We'll be pressing the tanks, priming the igniters, doing the final engine checkouts, retracting the strongback, and then getting that final go for launch. We're currently proceeding with the launch time of 11:25 Eastern. That is 23:25 Eastern. Let's continue to listen in.
Yeah, I'm getting more hopeful, guys. This could be the one. Yeah, there's no don't even say the word boat. We don't want to conjure the boats. Man. You guys can't jinx it. Come on. So we should see the different parts of the activity of how this vehicle prepares here. we're gonna get to see a little more of the. I like the nozzle camera because you're gonna get to see how the engines are kind of cycling up.
Stage 1 pneumatics and transition to helium.
All right, we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during flight, we'll pressurize the tanks using autogenous
For engine chill.
pressurization. As
Yeah.
you can see from these epic views, we are launching at night today, but in terms of our vehicle, it doesn't make a difference if we're launching during the day or at night. The systems operate the same. You are able to see those white clouds a little bit more clearly now. So that big white cloud you're seeing come out of the strong back is due to strong back chill operations. So we're chilling all of the ground equipment to try to get our locks as cold as possible for stage 2.
It's just part of operating a
Those smaller
cryogenic
white
system.
clouds that you saw earlier coming out of the vehicle at different levels are due to the venting of the chilled gas from the rocket. And that venting into the humid Florida air
Once
out
the
here
engines
is
light
what
up, I think
causes
that's
the gas
pretty
to
much headlights
condense
enough.
into vapor and look
Will
like
create
clouds.
quite a brilliant light, I would say.
You can also see the frost on the rocket and what looks to be small white pieces falling off. That's all just ice, and it's because of the chilled propellant inside. It's so cold that you'll see ice falling off the vehicle.
And that ice is not going to damage the vehicle. Like, the ice is not a structural issue. Like, that can
Stage 2
hit the side of the
secure for
vehicle. It
climbing.
won't be a problem.
Well, let's walk through the launch timeline now that we're getting closer.
Yeah, at T-minus 70 seconds, the vehicle will go into terminal count, and this is when the vehicle's internal flight computer takes control of the countdown. We'll then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6 seconds, we're going to see that blue fire and have ignition of those 9 beautiful 3D printed Aeon 1 engines. And then at T0, we will have liftoff.
Look at those
and
engines.
Terran 1
Oh, you
will
only showed
fly.
them for a second.
Shortly after, at T+2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. And then at T+12 seconds, we'll begin our pitch over program. So we'll go downrange in an easterly direction over the Atlantic Ocean. And then at T+80 seconds is that very important milestone of max Q, where the structural loads on the vehicle are the highest.
At approximately T plus 160 seconds, we'll get to main engine cutoff, or MECO, where the stage 1 engines will shut off. This is followed shortly by stage separation, and the Aeon vacuum will ignite. Aeon vacuum engine will ignite on the second stage. Second stage will burn for a little under 5 minutes. Then at approximately 463 seconds, we'll get to second engine cutoff, or SECO. We'll go ahead and tune back in to mission control.
So you may be wondering what max Q is.
Like
They
computer
keep
and vertical leveling.
They keep mentioning that this is the key target that they're trying to get to prove
As
the
a reminder,
technology.
GLHF is our maiden launch, so what we're really looking for here is to learn as much as possible and demonstrate the product concept. A big milestone will be reaching that point of maximum dynamic pressure, or max Q.
So the max Q is basically the point at which you have the maximum aerodynamic stress on the vehicle. So if you think about it, you have more
Stage 1
stress
igniters are
because
priming in.
you're going
Stage
faster
2
and
igniters
faster
flight target.
as you get higher.
We're now priming those igniters with gaseous oxygen and gaseous hydrogen.
But there's another effect, which is that the higher you go, the less dense the atmosphere
In
is.
just about 30 seconds, we're going to be looking for the transporter erector cradle to disengage.
And basically there's like a sweet spot where you're going really fast, but you're not quite high enough that the density is less. And that's the point where you basically have a peak in the aerodynamic
Stage 2 is on
density,
internal power.
a peak in the aerodynamic stress on the vehicle. And that's what we call this max Q value.
EE cradle disengaged.
So you
All
should
right,
see
now
the
those
strong
cradle
back
arms
retracting
are
now.
going to slowly release stage 2, so the strong back can retract. You can see the arms opening up there.
All right, guys, we're getting close. The vehicle is ready. We have had no technical hiccups so far. So you can see here they're just starting to do those gimbal tests.
Now you'll be able to
Watch
see
those
the
engines
stage 1
move.
engines gimbling or tilting as you see while we're completing those final thrust vector control health
It always
checks.
looks so cool when they all go together like that. This is like,
Stage 1 is on internal power.
they do a little dance there. Yeah, unfortunately the rocket engineers aren't very good at naming things. They just keep the variables.
The strong back will be retracting shortly here.
Yes, they're trying to reach orbit. So this is an orbital launch, their first orbital launch attempt.
Strong back is retracting.
And it would be a
There
first
you go.
for
We're
a
retracting
number of reasons.
that black truss structure to prepare for
Stage 2 TC checkup.
umbilical separation now that both stages are on internal power, and now we're doing those final thrust vector control health checks on the upper stage.
I'm pretty sure they're going to throttle down for max Q. I don't think they're just going to push straight through it. But I have never seen this one launch, obviously, so we're going to find out. This will be the first.
Of launch commit criteria.
We're coming up close to that T-minus 70
Wow,
seconds.
we are very closely approaching T-minus 1 minute.
That's the
I just want to
key
remind
milestone.
all of us here that what you're looking at on your screen is 85% 3D printed, and it is about to fly.
So this will be a first for majority 3D printed rocket. It will be a first for a Methalox rocket to orbit.
Next up, our range coordinator will ask the range for their final status.
And if successful, they would be the first private company to get a rocket to space on the first attempt. So this could be a lot of firsts all up in one vehicle.
Rock, report range status.
Range green.
Everything's green. Let's get past T-minus
That
70
was
seconds.
confirmation. The range is green for launch.
We're good, guys. It's going. We're in the last minute.
Propellant closing out.
It's gonna go.
Configured for launch.
It's gonna go.
Under 1 minute.
I think this is it.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away until the maiden launch of this vehicle. Good luck, Terran 1, and have fun. Here we go.
Okay, hopefully they can pass their launch criteria. So the engines are going to start at T-minus 6 seconds. And then it should release at T-minus 0.
9, T, 7, 6,
Here we go. Engines on.
1. Liftoff.
And it's going. It's going, guys. It's up. Here we go.
Terran 1 has cleared the tower.
Switch over maneuver started.
This thing is flying. How is this thing flying? This is crazy.
Look at that blue fire!
This is so cool. So this is the Methalox engine. That's why it has that kind of bluish green flame. It is. This is awesome. So max Q comes at T plus 80. That is such a cool flame, guys. This is so cool.
If you
I
can
cannot
hear me
emphasize
over
this.
the cheering, the vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is max Q around 80 seconds.
This has to be one of the most beautiful rocket plumes I've seen.
Get telemetry switch over at the ground station.
Oh, it's the future, guys. We are living in the future. Now we have 3D printed rockets. It just passed max Q.
Max Q.
That's it. It works.
We are on our way.
It works.
Making a new history. Terran came ready to play today. You
Look
just
at that
heard that
flame.
call out indicating Terran 1 just
Wow,
made it
look
through
at that picture.
Max Q. We just completed a major
Gorgeous
step in
picture.
proving to the world that 3D printed rockets are structurally viable.
Man, this is such a beautiful launch. I cannot with that blue color on the engine, it
Up
is
next,
just
we'll
so
be looking
cool
for
looking.
a call out that stage 1 performance is nominal.
Okay, we should be coming up on the end of this burn in about 20 seconds here. So that would complete the mission of the core stage. Basically a fully successful flight. Okay, that was just MECO. Engine is cut out. We should see that separation. It looks like we have the second engine. It's going. Second engine just started.
We're waiting for MECO and upper stage ignition.
Oh my
this
goodness.
means that we had a main engine cut off for stage 1, and directly following that we had second stage ignition, which you can see the Aeon vacuum engine in that beautiful view in the night sky. Reminder, there is no fairing for this maiden launch as we don't have a customer payload, but we do instead have a memento
Oh
of
man,
the
if this
first
works
ever
all the way,
circular test print.
if this thing goes all the way, that would be amazing. The first private company to ever get a thing to space on the first try. It's looking good, guys. This would be so huge. It can be done. Look at that thing
We are currently
gimbal.
standing by for an update on what's happening with the stage 2 engine.
Look at how that thing gimbals. It is so cool how it gimbals. So they're controlling the upper stage. It's like how it moves by just the engine moving around. That's how they control the rocket's flight's attitude. Oh man, this is really cool, guys. I'm telling you right now, this technology is gonna take over. Yeah. It's going to be a game changer. And Methalox engines, I think those are definitely here to stay. That's going to be the fuel of the future. Man. So yeah, we don't have the camera view from the second stage because of course they're prioritizing the data that's coming from the sensors. It could be that
this is the LD. There's been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
Okay, so they have an anomaly. Yeah, maybe something went wrong with that second stage. It did look like it tried to light, and maybe it didn't actually get the flame going. But I don't know if that's really the case because it's tough to see the flame when you're in space. Yeah, the CEO is actually pretty young. I think he's like in his 30s. But that's kind of the case for a lot of these young startup companies, so that's not too atypical. All right, so it looks like there could be a slight problem on the second stage. It's definitely looking a little more.
As you heard from our launch director, we did have an anomaly with stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at max Q, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @RelativitySpace on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran R. What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
Yeah, so
And I'm
it looks like they did have an anomaly.
Thank you.
Uh,
See you next time.
This is kind of part of the process, I guess. It looks like they had something wrong with that second stage ignition, I think. I think that would make sense as to what happened. But it's still amazing, an amazingly successful mission, because they actually were able to get all the way to actually getting to the second stage component. So the fact that the first stage performed flawlessly, no issues, they got the stage separation, that's already like big for a launch company to get that far. Based on the footage, it looked like they had an issue with igniting the second stage. Like you saw, it kind of had some flashes that were coming out of the engine bell. And the reason, like the way a methane engine starts usually is by using like basically just a spark plug kind of. So they just shoot sparks at it until it ignites. So maybe it could be like an issue with that. But definitely stay tuned with them to see like what the issue was. Their Relativity is super like open about sharing their what's going on underneath the hood and what their issues are and stuff. So if you're interested in that kind of stuff, they'll definitely be sharing the information and stuff. Yeah, I'm sure they're going to be back on the pad relatively quickly. Again, they 3D print rockets, so it doesn't take them that long to make a new one. Literally just gotta fire up the 3D printer and print a new one, right? Yeah, I thank you guys for hanging out and talking about rockets for a little bit. I think we're all of the same mind and want to see these rockets take off and see the technology develop. And I think we're all excited to see what's possible in the realm of 3D printing and what's in store for potential future rocket technology. So yeah, we'll be here next time as well, hopefully, assuming that it's at a time that's possible for me. Hopefully to stream the next attempt of the Relativity Space's Terran 1. In the meantime, guys, thanks for joining, and have a great rest of your evening. And maybe give that launch a rewatch, because my God, those engines looked absolutely gorgeous. I've never seen a Methalox engine fire at night before. I've only seen the SpaceX ones. But honestly, those plumes were fantastically gorgeous. I hope everyone starts using methane. It looks way better than kerosene. I'm now a methane fan. All right, guys. I hope that you continue to expand your knowledge in the realm of rocketry and keep seeking and helping those that are developing these technologies. Keep helping them out and giving them support, because the engineers are working hard. It would be nice to, it's good to have the people cheering them on the sides. Anyways, in the meantime, remember to expand your horizons.